Welcome back. In this video, we're going to work on some more vocabulary. We're going to introduce exponents, talk about our order of operations, or Pemdas, and we'll talk about the difference between algebraic expressions and algebraic equations. So, beginning with exponential notation allows us to write multiplication of a repeated factor or factors in a compact form. So the exponential expression 2 cubed really represents 2 times 2 times 2. So 2 multiplied 3 times in a row. Okay, and we could have 5 all raised to the 7th power, which is 5 times 5 times 5, 7 times. Now, a couple things with exponential expressions you need to understand is our number being multiplied, or our factor, that is our base. So the base, and the power is our exponent. So 7 here, or 3 and 2 cubed, is our exponent. So we have to know the difference between the base and the exponent. So the exponent is the number of times something is repeated, or the number of times the base is repeated. Now, working with exponents, be careful with things like, the opposite of 4 squared versus the opposite of 4 squared. So this is two different things. On the left, the only thing that's being squared is 4. This is really -1 times 4 times 4, or the opposite of 16. The negative sign here is not being squared, just the 4. Now with parentheses, now this is a little different. That is the opposite of 4 times the opposite of 4, or our negative sign is being squared. That is a positive 16. So be careful. It's a very common mistake that young math students make when working with exponents, is oftentimes they forget what the exponent is being applied to. Here it's being applied to just the 4 and not the opposite sign. Here it's being applied to both the opposite sign and the 4 because of the parentheses. And that's a nice lead into our order of operations. Okay? You may have learned in grade school our order of operations, or please excuse my dear Aunt Sally. It tells us what sequence to simplify a mathematical expression. I'll talk about mathematical expressions in just a minute. But this is this Pemdas that you saw at the beginning. That's our order of operations. And it's just a mnemonic device, please excuse my dear Aunt Sally, to help us remember the sequence or the order in which to simplify a mathematical expression. So we want to start with parentheses. So if possible, we simplify our parentheses, or within grouping symbols, parentheses, brackets. We can even include absolute value bars here, and sometimes even fraction bars. We might simplify the numerator separate from the denominator. That is still, the fraction bar is still a grouping symbol. Then second, we would apply any exponents and evaluate any exponential expressions. Third, we would multiply or divide from left to right. So be careful here. This doesn't mean we do all the multiplication first and then we do all the division first. We multiply from left to right, whichever comes first. So really, if division came before multiplication or to the left of it, we would divide first. So these are kind of compressed together. We multiply and divide before we do any adding and subtracting. Okay, so we could actually write this as division, then multiplication, and we could write it subtraction, then addition, depending on what comes first as you read from left to right. And then finally, as we have here, then you do your addition or subtraction as we move from left to right. Okay, and those two, of course, could be flipped. If subtraction comes to the left of addition, we would do the subtraction first. So, for example, I might ask you to simplify 1 plus the absolute value of 4 minus 7 plus 3 squared all over 8 minus 5. So we could do some of this. We've got grouping symbols here with the absolute value. So we have 1 plus the absolute value of negative 3 plus, now we can do the 3 squared. We can do that. Plus 9 all over, and 8 minus 5 is 3. Now we can't cancel the 9 and the 3. That would violate our order of operations. We can't make negative 3 plus 9 because that would violate the order of operations. We have to apply this absolute value first. So applying the absolute value, we end up with 1 plus a positive 3 plus 9 over 3. And again, we can't do any canceling or simplifying here. We need to add all this stuff together in the numerator first and then divide by 3. So 1 plus 3 is 4, plus 9 is 13 thirds, and that is our final answer. Okay? So there's an example of the kind of thing you would do following the order of operations. A few more definitions, more vocabulary. A variable. Algebra, we deal a lot with variables. We'll have some answers will just have letters in them. A variable is a symbol, usually a letter, to represent an unknown number or value. An algebraic expression is a collection of numbers, variables, operation symbols, and grouping symbols, okay, in which there is no equal sign. If there's no equal sign, we've got ourselves an expression. So some typical algebraic expressions, well, 2x is an algebraic expression. The integer negative 3 is an algebraic expression. 3y squared plus 6x plus 1 over 4 is an algebraic expression. ax squared plus bx plus c is an algebraic expression. Now we can evaluate algebraic expressions, and that's to find the numerical value once we know the value of the variables. So if we had, I don't think I have an example of one, but if we had 2x plus 3, and then we said let x equal 7, well, that becomes 2 times 7, because x is 7, plus 3 equals 17. So we have evaluated that expression if x is 7. Okay? An algebraic equation, that is a mathematical statement that two algebraic expressions have the same or equal value. An algebraic equation will always have an equal sign. So some examples of equations: 2x minus 3 equals 7. That's an algebraic equation. 3x, 3 times the quantity x plus 4 equals 6 times the quantity x minus 7 is an algebraic equation. We've got two expressions connected with an equal sign, so these two expressions are equivalent. We will be doing word problems this year. There's some hints here for translating English into algebra. That's what we're doing. We want to translate our English sentences into algebraic expressions and equations, or we're translating English to math. Okay, some more simple ones. Take a look at this table. It's also in your book. But if you see like sum or plus or added to, all these, that is going to be addition. Subtraction is a little more challenging. Okay, subtracted from, less than, decreased by. We have to take a look at some of these because these are a little bit more difficult to translate. We have to be careful what comes first. subtract 10 from 7. Well, that's 7 minus 10, versus we could say 10 is subtracted from x. Well, that's x minus 10. So you got to be careful with those kinds of things. Multiplication, common one is of, or product, times, multiply, twice, triple, that kind of stuff. Of is probably one we'll see quite often. And division, quotient, divided by, into, or ratio. And then equality or equal sign, probably the most common thing you'll see is. You see is, gotta think, that's my equal sign there. That's my balancing my two expressions. So here's some I want you really to be careful with, especially with subtraction. Subtraction and division order really matters. So like if we have a number decreased by 10, well, we don't know what the number is, and we're decreasing by 10, that is going to be some number x minus 10. Versus 10 decreased by a number, a lot of guys will do x minus 10, but that's 10. We're starting with 10, and we're taking something away, decreased by some number x. 10 subtracted from a number, well, that's what we have right above here. 10 subtracted from a number. Okay, so I have a number, some number x, and I'm subtracting 10. A number subtracted from 10, well, that's again what we have above. I have a number, I'm subtracting it from 10. I have 10, I'm subtracting something away, 10 minus x. 10 less than a number, well, I'm at least being consistent here. 10 less than a number, again, is going to be x minus 10 versus a number less than 10. Taking some number away from 10, 10 minus x. So you got to be careful with these. You've got to read, and sometimes you have to think, and you might have to put numbers in. Use an example in your head. Okay? So be careful with that. So that wraps up our lesson on section 1.4, your order of operations, and some introduction to exponents, and we will see you in class.